my name is Rocio Coleman. Thank you for coming over to this professional development of understanding by design. We have currently been wanting to switch over to understanding by design for the last 2 or 3 years. We are not currently using this design in our district, but like I said, we're trying to show other schools the benefits of using understanding by design for our curriculum, so that way we can help close our achievement gaps for our students. So understanding by design isn't new. There are actually other districts that are using it and implementing this into their curriculum. So before we start, I want you to think about when you first wanted to buy a house. When you start looking around a house and you kind of get an idea of how you want your house to look like, what are you particularly looking for? When you go into a house or a model house, they already have floor plans ready for you. And you start looking at it, you start saying, okay, I like this, I like that, but I kind of want to move the family room to the other side, or the dining room down here, or maybe I want to make this, instead of a 4-car garage, a 5-car garage. So you have an idea, you have what you want in that set. Once you pick your floor plan, then we start building. Then we start buying the bricks. We start buying all the stuff needed to build a house. So kind of with backwards design is exactly how you see it here with the floor plan. We want to make sure we know exactly what our students need or what we want. And once we have this idea down and set, then we can actually start going out and getting everything we need to build the idea of a perfect home. So going on to what we are as teachers, take a minute to think about why you are a teacher. What made you come into the field of education? What made you decide to be a teacher? This doesn't have to be just a particular subject. It can be music, it can be coaching, it can be a math teacher, a science teacher, as a teacher. But just take a minute to think about why you're here as a teacher. So we'll take that minute. Okay, so for me, the reason why I wanted to be a teacher, I actually didn't. So I went to school and got my degree to just be a mathematician. I got out and I started applying to jobs, and I was getting interviews, and then my cousin actually said that she got an interview to be a teacher. So she went in, and I decided that same day that I was going to go apply to be a teacher. So I went in, started applying to a couple of districts, and I got 2 interviews. One interview was actually in full Spanish, so that was fun. But I got the interview, got the job. It was all really fast paced because a week later I had my first day of school. So I stood outside the hallway and kids were walking by, and then one kid asked me where the bathroom was, and I had no idea where the bathroom was. I said, I think it's that way, and the bathroom was actually 2 doors down. So I didn't really have a reason to be a teacher. After my first year, I realized that I do like helping students. I do like not just showing the material and showing the passion that I have for math, I like having kids know that math doesn't have to just be about numbers. It can be about learning how to think critically and how to solve problems. So that was kind of my reasoning for wanting to continuing the teaching field, because since I have a degree in math, I could just be anything else besides a math teacher, right? So, but I decided to stay in the teaching field because I wanted to help kids. I wanted to teach them not just how to do math, but how to problem solve as well. So we have a TEK here, and this is the question I like to ask a lot of people, to just take a minute to think about this TEK. This is a math TEK, so for anyone that's not in the in the content of math, this may be a little bit hard, but it says generate equivalent expressions using properties of operations: inverse, identity, commutative, associative, and distributive properties. Now the question I like to ask is typically, where do we see this TEK at? When do you first see this TEK at? And a lot of people tell me they see it in 8th grade or freshman, Algebra 1. That's when they first see it. But in reality, we actually see this in 6th grade. So the problem here comes with a lot of teachers, a lot of first-year teachers come in and they think, let's just teach. But the thing is, we actually have to know and understand these TEKs. And that's kind of how backwards design works, is you have to know these TEKs and know where they came from and know when we start teaching these TEKs for the kids. So this TEK, which talks about the distributive property, which is the important one, is first taught in 6th grade. That means since 6th grade, students have been seeing this over and over and over again, and we test them in Algebra 1. So, let me So for our objectives today, we're going to be we're going to be knowing the understanding by design process, and then I'm going to show you how we use it properly. That's going to be our objectives. And so this is what our agenda is going to look like. We're going to talk about what our traditional model looks like. The traditional model is typically what you're used to basically seeing, what people think teaching is like. And then afterwards, I'm going to talk about backwards design, or understanding by design. Those are the 2 interchangeable words, UBD. And then we're going to look at a template, so that way you can see how we use this in the curriculum. So, with traditional model, this is typically how we make our curriculum. First thing we do is we start thinking, okay, we want to do a fun game for the kids, or a fun activity, or a fun worksheet. Let's go on Pinterest. That's the big one that teachers always use. Let's go on Pinterest and figure out what types of activities we can do. We can do bingo, we can do a scavenger hunt, so many different activities we can do. That's typically the first thing teachers want to do, especially first new year teachers who haven't even had experience as a student teacher, and so on. So typically we like to pick the activities. After that, we start to make the test. We say, okay, well, let's make the test. Let's make sure we put something about, a problem that we kind of use in this worksheet, and then a problem that we use in that worksheet, and then, maybe from this worksheet too. So then after that, we start looking at the results, and we start realizing that our data from the test that we created, maybe are good or maybe are bad. And then we test them on the state or on the district assessments, and then they completely fail or bomb it. So that is the traditional model that we are used to kind of seeing. So again, whenever we think about traditional modeling, it's typically teacher-centered or instructional-centered here. We typically, again, look for the textbook, we look for the activities, we put all of that in a worksheet, we use that worksheet to create the test, and then we use that test to assess the kids, and we don't even know if that test is aligned correctly to the state or the district standards, or even the curriculum. And then with traditional model, the problem that happens is a lot of our kids, whenever we're doing these worksheets, or whenever we're playing these, so to say, fun games, or whenever we're starting to take a test, these are the questions the kids always ask. They start asking, why am I doing this? What is the point of this? What's the purpose of all this? And what am I going to get out of this? Why am I learning this? Why do I need to do this? When am I going to use this for the future in the real world? That's the kind of questions the kids start to ask whenever we do start to do the traditional model of let's find a fun activity, let's do homework on that fun activity, let's make a test from that fun activity, and then, let's take the star. And then you realize again that they're not aligned with each other at all. Understanding by design, why we want to use it and why we like to use it. So here are 4 different research articles that when we use backwards design, it says it actually improves attitudes in the classroom. So in one research study in 2002, there has been a study saying that students' attitudes have been improved and have gone up and they've become more positive. Another research showed that there was an increase in student performance. So in other words, our scores have been going up, which is good. And that would be our classroom scores, our district assessments, and then our state assessments as well. The other thing is students start to get really involved. Since understanding by design is student-centered, the kids you realize that the kids are discovering things on their own. So in other words, they become more involved and more curious, and they want to know more why. They don't ask those questions of what is the point of this, when am I going to use this in the real world, and questions like that. The last thing, or one of the last things, because there's actually more, is that in 2011, there's a research that showed that it reduced student achievement gap. So we currently have a huge gap. I believe there's a 15% poverty rate right now. So we have about a good chunk of our kids down here on the spectrum, and then a good chunk of them up here. There's a huge gap of learning, so we're trying to close that gap, and obviously, so to say, bring these low kids up, so that way, we can close the achievement gap and bring up our scores. And so understanding by design, these are just 4 of the research things that have been showing improvement and positive impacts into our education. And this is the reason why we want to use these in our classrooms, in our schools, and in our districts. So with understanding by design, there are 3 stages. We got the learning goals, the learning outcomes, and then the learning plans. And the first part we're going to look at is stage 1. So with stage 1, there's kind of a lot in stage 1, but the big thing is when we come in as teachers, we want to think about what is the goal. That's the first thing you should be thinking of when you walk in to create your lesson plans in your PLCs. What is your goal? What do you want your students to understand? Now, typically this goal is basically your standard, okay? So what do you want to get out of this? What do you want the students to be like, bam, I got this? So that's the first thing you want to think about. Now, from that goal, you have to think about now the transfer page, okay? So in other words, how are they going to use this goal that you have? How are they going to use that goal outside the classroom? How are they going to use it in the real world, in their workforce when they graduate? When and how are they going to use it based off that goal that you made? From there, you also have to think about what is the meaning behind it. So you have a goal, okay? And then you have a reason on how you're going to use this outside. And then you have to think about the meaning. What are the specific things that you want to address? So what are the essential questions here? And that's going to frame the lesson. And then the last part is, again, from that goal, what do you want the big picture to be? You have to think about the little things, okay? So not only do you have your big goal here, but you have to think about the little things in the lessons. What do you want them to get out of it? What little details are you missing that they can use in the real world, and part of the essential question?
I'm going to give you a minute to look at this template or example stage 1.
So here's an example of what a stage 1 looks like. We have, and this one is going to be our goal is going to be the standard. So once you have your standard, you think about your transfer. So in this in this section here, it says the students will use and recognize certain keys. Okay? And then students will recognize how scientific knowledge is subject to change as new evidence becomes available, or as new theories cause scientists to look at old observations differently. So that's going to be the transfer. That's how they're going to use this stuff outside of school. Then you have to think about the meaning behind it. So in other words, the meaning is going to be the method involves in creating a classification system, and then the reasons and importance of classifying in science as well as in our daily lives. So you're taking your goal and you're thinking about the meaning behind it. How are they going to use it outside and make it meaningful? And then you have the essential questions. Why are we classifying there? Is there a right way to classify it? And why is a dog not a fish? So just essential questions of what the kids what they should be asking. And then the last thing are the details. So over here they're going to compare their own classification methods and difficulties to those of the professional scientists. So this is stage 1. This is what the curriculum team is typically creating. And our curriculum team, or your curriculum writers, typically spend a long time just writing this one stage for this one standard. So what they have on there is really important. So stage 2 is a little bit more in depth. Once you have your goal, then you start thinking about, okay, how can I make sure the kids know the goal? How do I know that the kids have mastered the goal? So this is where we start thinking about, what can we do? Do we test them? Do we make a project? Do we make them do a presentation? How do we know that the kids understand the goal? And this can be, again, different ways: presentation, projects, tests, quizzes, or it can be informal or formal assessments. A lot of times you can just be walking around the classroom, and do you hear the conversations that they're having? Are they having conversations about the goal that you made? That could be an assessment. Okay, and then when it says other evidence, again, it's not just focusing on tests. It can be other things, like you walking around the classroom and hearing the conversations the kids are having, and other conversations directed to or related to the goal that you have made.
I'm going to give you another minute here to look at stage 2.
So again, here's an example. So performance tasks here is students will construct their own key or flow chart to classify 20 different household items. So these kids don't have to do a test to prove that they understand the goal. They're just gonna make a flow chart. That's it. That's how the teacher's gonna know that the students understand the concept. It's not a test, it's not a presentation, it's not a quiz. They just have to create a flow chart, and it can be a poster. And then other evidence is the kids will be working in groups, and the groups will present. So that's how the teacher's gonna know that the students have reached their goal, or the goal that they want them to have is they're gonna create a flow chart, and once the flow chart is created in groups, the groups will present to the class. And from there, the teacher will see if the students have mastered the goal. Okay, and the last part is how can we make this, so to say, fun? Okay, what activities, what can we do? It doesn't have to just be me standing here and talking. It can be different activities. All right, so that's where you start thinking about, okay, now I know what the goal is. I know how I'm gonna assess them. Okay, you're gonna assess them through a flow chart. How can I do this now? What can I do for the kids to learn this?
And I'm gonna give you another minute to look at stage 3.
And this is sort of say where your lesson plan comes in fact. So over here for the lesson plan, the learning plan, it says here that we are going to get different clothings from home, and then you're gonna have 3 construction papers, markers, and the flow charts, then some unique shoes. And so for the first 10 minutes of the class, they're going to introduce, the teacher will introduce the assignment, and then for 30 minutes the kids will be working, and then for 10 minutes they're going to do the presentation. And so from here you can see it's very detailed. It shows like what the classroom will look like and what kind of questions will the teacher be asking. So here's some questions on here. Do they have any troubles or difficulties? This is what I would be assessing on. Why is it the best way to classify these items? Could you have classified them differently? These are also questions that as the kids are working within that 30-minute range, the teacher can walk around and say, hey, is this the best way to classify something? Or can you classify it a different way? So this is a very detailed lesson plan for that one activity, that one goal that you want them to have. And now looking at this, now you think, okay, so these kids are having fun. I'm not just standing up here and I'm not talking about, science and the kids are falling asleep, because now I have a fun activity where I'm bringing in clothes from home, and the kids are going to be constructing something. They're going to be coloring a poster, and then they're going to come up here and present. It's not the typical classroom anymore. It's not direct instruction where I'm standing here and talking for 20-30 minutes and then allowing you to do a worksheet, sending you to do homework. You come back and I give you a test. That's not how it is anymore, okay? Now this is more student-centered, okay? This is more fun. The kids are involved and they're relating the lesson to something that's not just in a classroom, but something that they'll use outside as well. Okay, so here are some examples of some templates. Different classrooms, different PLCs, different districts, different campuses have different ways of designing their own stuff. Our campus currently is creating one. and it's actually neither of these three, but it just kind of tells you a little bit that there are different ways of structuring this, and you won't always see that stage 1, stage 2, stage 3. Okay, so we're going to try creating one for ourselves. This is actually an Algebra 1 TEK. So as you know, the kids that are in high school, they are going to be taking 5 assessments, and they have to have 3 out of those 5 to pass in order to graduate. If the kids don't pass 3 out of the 5, then they are not allowed to graduate per state law. Okay, so one of them is Algebra 1. So we got Algebra 1, English 1, English 2, Biology, and US History. So for Algebra 1, we have here a TEK A5A, a readiness TEK. So it says linear functions, equations, and inequalities. The student applies the mathematical process standard to solve with and without technology, linear equations, and evaluate the reasonableness of the solutions. The student is expected to solve linear equations with one variable, including those for which the application of a distributive property is necessary and for which variables are included on both sides. Okay? That one topic, that one TEK, we're going to break it down. We're going to show you what the curriculum team does and how we can make it more student-centered. So first thing we want to go ahead and do, what the curriculum team is doing, is we want to see how are these kids going to see the question on the star. So I went ahead and pulled out, this one has four questions from the star. And this is how the kids will see it. Back in the day, when we had TAKS, it was simple. It was just solve for X. Simple. Now you have questions like this where it says, what value of n makes this equation true? It's not what's solve for X anymore. It's none of that. Then over here you have, what is the solution to this? And then you have, you know, a non-multiple choice one. And then you have one that says, what value of X makes this equation true? So it's good to see how the kids are going to be asking this, or how the kids are going to be seeing this, because you want to make sure that your activities and your homeworks and your quizzes and your tests look just like this. So that way when the kids come to STAR, they're not surprised with the format of how this looks. So it's always important to look back to see how they're going to assess it. From here, we need to unpack the TEKs. So unpacking the TEKs, we're going to focus on that TEK that says linear equations, all right? And then we have one variable. So we're going to be looking at linear functions, because in algebra there's actually 4 different equations we'll be looking at. We got linear, quadratic, exponential, and then logarithm. So we're going to be looking at just linear, one variable, so that means x or only y or only z or only a, distributive property, and then variables are going to be on both sides. That's what you need to know about that one TEK. So the show is kind of like, how are the kids going to see it? Again, going back to the last slide, the kids are going to be seeing it like this. You're going to have decimals, you're going to have negatives, you're going to have positives, you're going to have x's, you're going to have parentheses. That's how they're going to see it. So this is how they need to see it in the homework. They need to see it like this on their tests. They need to see it on the lessons just like this. So that way when they come for the test, it looks exactly the same. So that's the no-show unpacking the TEKs. From here is where we go into, so to say, stage 2, and we start saying, okay, how do we want to assess these kids? Okay, and it doesn't have to be the projects and assessment. In the last one that we had, the kids did a flow chart. Okay, that's great. You can do a flow chart, you can do a presentation. This is where the teacher gets creative. This is where you come together as a PLC, or your curriculum writers come together and they think, okay, how can we assess these kids to make sure they've understood this? Okay, and again, it doesn't have to be a test, it doesn't have to be a quiz. Once you've decided what you want yours to be, so if we want to do a flow chart again, then we think, okay, how can we make this for all of our kids who are ELL, our English language learners, you know? And it doesn't have to just be kids that only know Spanish. It can be the kids that don't know English and are Vietnamese or are Chinese or just, you know, from different other places. And then how can we incorporate technology? Can we bring in some calculators? Can we bring in other types of things besides a calculator? And then so in general, how can we make it fun and different for the kids? And so that way everyone is able to participate. Especially if we have some SPED kids or we have some 504 kids, how can we make sure that they are also learning this and equally tested? Once we have that, we need to start thinking of what did we do wrong. So let's say I decided to do the flow chart again for this TEK, okay, and I wanted the kids to do a flow chart on how to solve for x with a distributive property in the one variable, okay? What went wrong? So maybe the kids are coming up here and presenting, and maybe I said only one person needs to talk, and that means only one person did the work. Maybe that's where I went wrong. Or maybe I should have said everyone that comes up and presents needs to talk for at least a minute. Or maybe I graded it the wrong way. Or maybe I should have let students grade it. This is where you really start to think about your assessment and then what did you do wrong and what went right. So that way you don't make the same mistake again. Once you figure that out, this is where you start thinking about how can I reteach this? How can I bring this back in tomorrow or in 2 days or in a week or in a month? So because not every kid's gonna get it right the first time. So I need to figure out a way to bring it back so that way the kids can know in case they miss the lesson or in case they miss the TEK.
So I want you to go ahead and take a minute to look at this poster and kind of see how we created a flow chart for understanding by design.
So here is the overall understanding by design. Again, we start here with the STAR, with the state assessment. You start thinking about, okay, what does this look like? What do the kids need to know? What is the standard? We start unpacking the TEKs. Okay, we start looking to see what does this TEK actually want? Because a lot of the mistakes that sometimes teachers make is they just look and see, oh, all you have to do is solve for X. Okay, that's it. And then you don't address things like decimals or maybe even fractions. And then all of a sudden the kids come to the STAR test and there's decimals and there's fractions and the kids have never seen that before and then they start failing. And then it's all on us because we didn't look at the test. We didn't see what are the kids gonna see for the test. So making sure that you really unpack the TEKs and see, okay, that there's decimals involved, there's distributive property, there's only one variable and you do it on both sides. Then after that, you start thinking about how you want to test them. How do you want the kids to, how do you want to check for understanding? And the flow chart was a really good idea of showing, hey, it doesn't have to be a test. In this case, it could be a simple DOL, checking for understanding, you know, an exit ticket or a quick write. Something that I've seen teachers do is they'll have the students create a question, say, hey, create a question for me on you know, what we just did. And that's it. Simple, quick and easy. Turn it in. Kids walk out. You have an exit ticket and you can easily check it as they're going in and out. Afterwards, you start thinking about, okay, how can I make this different for everyone? Because I want to make sure I've reached every student. All the kids that are, you know, low versus all the kids that are high. You want to make sure you tackle them all. Once you've done your assessment, then go ahead and think about what did you do wrong. In the exit ticket that we did you give them enough time? Did you give them only 2 minutes? Did you give them 5 minutes? Maybe you didn't give directions clear. Maybe you need to show an example next time. What went wrong and what went right. There's always room for improvement. And then obviously the last one's going to be, okay, here are my, you know, here are my exit tickets. How can I bring this back in? Did every kid understand it? No? Okay, how can I bring it back in? That's understanding by design. And so here is just kind of a breakdown of the difference between the two, which is what we used to do about 10 years ago and what we're trying to get to now, where what we did before was we would look for fun activities, fun games that we could do with the kids, something fun for them, and then the kids come to the test and that fun activity had nothing to do with the test. Whereas over here, we're looking at the test first. We're seeing what the test is, what the kids are gonna see. And then we create the fun activities afterwards. That's more student-centered. The kids start to discover and learn more and don't ask questions like, why are we using this? When are we gonna use this in the real world? How is this gonna help me? This is a waste of my time and stuff like that. And those are the more teacher-centered type of things. And I think that's it. Any questions? Thank you guys so much for coming. Hope you guys have a good day.